Good morning, all of you. So, in today's class, we will learn uncontrolled chain reaction, controlled chain reaction, and nuclear reactor. Okay. So, first of all, uncontrolled chain reaction. See here, uncontrolled means on which we don't have control. Okay. Like that, if any chain reaction is taking place, that is nothing but what? Uncontrolled chain reaction. So, what happens in this uncontrolled chain reaction? So more than one of the neutrons, more than one of the neutrons produced in a particular fission. Fission, fission means what? Splitting of heavy nucleus into two lighter nuclei. That is what fission process is. So in particular fission cause further fissions. Cause further fissions. Cause further fissions. And here whole substance fission within a fraction of second. Whole substance fissioned within fraction of second. Means what happens here in uncontrolled chain reaction? First, if suppose once one neutron will get emitted from first fission, that neutron or more than one of the neutrons will be the reason for other fissions. Okay. For example, if generally we will speak atom bomb is there, how spontaneously everything is getting destroyed. So like that, here also, if any one heavy nuclei is there, it will get fissioned within fraction of second because so many neutrons are responsible for chain reaction, and that is uncontrolled, which we cannot control. Once started, it will finish until unless that complete nuclei is going to fission. Okay, so like that. This is what uncontrolled chain reaction. Next one is controlled chain reaction. Controlled chain reaction means what? Reactions which we can control, Okay, so let's see what happens in controlled chain reaction and what is the use of this controlled chain reaction. That is what are the applications that also we will see. So here only one neutron, only one of the neutrons, only one of the neutrons produced in each fission is able to cause further fission. is able to cause further fission. And this principle, that is control chain reaction, where we are using this, we are using in nuclear reactor. Okay, this principle we are using in control, that is control chain reaction, where in nuclear reactor, and whatever the energy is getting released, that can be used for peaceful purposes. Okay, energy released can be used for general purpose. Okay, energy release can be used for general purposes. Okay, so you understood now. In uncontrolled chain reaction, more than one neutron is responsible for further fissions, whereas in controlled chain reaction, only one of the neutron is responsible for fission. Got it? That is what the basic difference. Whereas here, this whole substance get fission within fraction of second. It depends. Okay, if you are stopping that neutron, then it may take so much time to fission process or whatever the nuclei, or the complete fissionate of that particular nuclei. It will take so much time. That depends on us. Okay, that is what controlled chain reaction. Understand? So first note down these points. Okay, finished. Okay, let's move ahead, and we will see now what is this nuclear reactor. Okay, what is the nuclear reactor? So first of all, let's see pointwise. What is this nuclear reactor? It is a device. It is a device in which nuclear fission can be carried out, in which nuclear fission can be carried out, nuclear fission can be carried out through sustained and a controlled chain reaction. Okay, so if they are asking you what is the principle of nuclear reactor, then you can say that the principle of control, what you can say, nuclear reactor is controlled chain reaction, right? This nuclear reactor also called as atomic pile. Okay, also called atomic pile. Now let's draw the diagram of this nuclear reactor. I am giving you a very simple diagram. So you can see here. Just see how I'm drawing, like that only you can also draw. Just give some names. Reflector. These are the control rods, and this is steam for turbine, steam to turbine, and here water from condenser. This is coolant. Okay, these are the names you can give. Now let's see what it consists. So first one is nuclear fuel, and clad. Nuclear fuel and clad. What is this? So see, the fissionable material used in the reactor is called nuclear fuel. Is called nuclear fuel. And what we are using, for example, uranium 235, uranium 238, or plutonium 236 are used as a fuel. Okay, and these fuel rods are tightly sealed in aluminum cylinders. are tightly sealed in aluminum cylinders. Next one, moderator. What is the moderator? Moderators are used to slow down the fast moving neutrons. Moderators are used to slow down fast moving neutrons. Just what you have to do, what are the parts are there? No, just write one function and example. That's it. And here, heavy water, comma, graphite are used as moderators. Heavy water and graphite are used as a moderators. Okay. Note down this and draw the diagram. Just one part, its function and what we are using as a, that you write about these 5 parts or in these 5 parts. Yes, finished. Okay, let's move ahead. Next part, that is control rods. Third number. What is use of this control rods? Now see, control rods in name itself, what it suggests, it controls something. Okay, so what it controls? So control rods absorb the neutrons, absorb the neutrons and control the chain reaction. And cadmium and boron rods are used as control rods. Okay, next one, fourth one, that is radiation shielding. Or you can say protective shielding also. This radiation shielding, what it or what is use of this? See, during reaction, what happens? Harmful radiations will come out or harmful radiations will get emitted. Then to protect human body from that radiations, because that are dangerous for our body, what we are doing, we are using thick walls of cement, concrete and lead, so that we will get protection from these harmful radiations. Okay, so nuclear radiations are harmful to our body. Nuclear radiations are harmful to human body, or harmful for human body. To protect these radiations, to protect these radiations, to protect these radiations, thick walls of cement, thick walls of cement, concrete and leads is provided around the reactor. Okay, next point, coolant. What is the function of coolant? Now, the heat will generate during this reaction, and this generated heat we will pass through a coolant, so that this coolant is something like water, so that coolant will get converted into high pressurized steam, and that steam we will use to rotate turbines to produce electricity. That is what the function of this coolant is, right? So see, the heat generated in a fuel elements, in a fuel elements is removed by using a suitable coolant, to flow around them. The coolant used are water, molten sodium, etc. Got it? Right? So these are the 5 basic parts and their function of nuclear reactor. This is theoretical part. Okay. Now working, how to write, even you can write in your own language. So let's see how to write this working of this nuclear reactor. So see first point how I am writing. Uranium fuel rods. Uranium fuel rods are placed in the aluminum cylinders which are separated by some distance. Which are separated by some distance. Cadmium or boron are placed in the holes of graphite block. Cadmium or boron are placed in the holes of graphite block. Neutrons liberated. Neutrons, this is complete theoretical part. Neutrons liberated behave as a thermal neutrons. Behave as thermal neutrons. These neutrons are responsible responsible for carrying out chain reaction. And next one, the heat generated is used to generate high pressure steam to rotate turbines to produce electricity. Okay, so what are the uses? Uses number one, to produce nuclear fuel. That is plutonium. And second one, to produce electricity. This is what general purpose use of this nuclear reactor. So what is there in this nuclear reactor, you understood now. See, one more time I am revising. First of all, this nuclear reactor is nothing but It is one device which works on the principle of control chain reaction. There are some parts, okay? Nuclear fuel, moderator, control rod, radiation shielding, coolant, okay? So these are the parts, how they are functioning and what we are using as that we have seen. Next one, their work, it's working, and what is the use of this nuclear reactor? That is to produce nuclear fuel or to produce electricity. Understood? So one time revise this, right? Got it? Understood? Clear? Read once and we will stop here for today. Bye.